Okay, hi. Back after the short pause. So I'd like to introduce our next speaker. That's Visa-Valtteri Pimia. He's known in the demo scene as visy and has experimented with demo art since 2001, and he has been interested in the artistic possibilities of computers since laying his eyes on the Commodore 64. Working with Trilobit and Belotrip, he is best known for demos for 8-bit devices such as the Nintendo NES and the Atari 2600 console, and he has been homebrewing everything from games to glitchfest on all kinds of imaginable computers and console platforms. Professionally, he's worked on game tech and mobile apps for companies like SCE, Samsung, Remedy, and others. He's a passionate gamer that I saw myself, and he helps run the indie game studio Hyperspace Yard. So have fun with Visa.
Hello, can everybody hear me? Good. So let's get to it. So I'm Visa, and I've been a software developer pretty much all my life. Since I was a 5-year-old, I've been working on BASIC. That was the most important thing on the computer for me, that it was programmable. I could do my own adventure games there. And I've been interested in virtual reality ever since I saw it on a PC. So that was back in '94, and the game I think was Descent playing. I don't remember where I saw it, maybe some sort of computer store in Finland, but I saw Descent playing there. And even though the Helmet Forte VFX1 was horrible, I knew that was going to be the future of gaming at some point. It just took a bit more than I expected. So yeah, I'm a digital artist and a demo scener as well, so I've been in the demo scene since 2003, so just about 10 years. And work for Sony, doing the PlayStation 4 kiosk unit software. If you played around with that, I did some of the interface programming there and design. Worked GPU research for Samsung on Galaxy devices. Worked on Death Rally and Alan Wake at Remedy and various other companies and game studios in the past. And right now I have my own game studio in Finland called Hyperspace Yard. We're working on our third game right now, hopefully coming out somewhere in the next few years. So let's get to history of VR just as an introduction of what virtual reality and augmented reality is. So it all started from Sensorama and Experience Theater by Morten Heilig. So this was a stereoscopic and audio experience, and Morten even wanted to have smelloscope there as well, so you could smell the fresh flowers at some point. This was the first rudimentary stereoscopic display available, and you used it in a booth like that. Straight out of Futurama, if you ask me. Probably won't be a suicide booth though. Then in the 60s, you got Army meddling around with things again, so you got a visual flight simulator with some virtual reality elements from Thomas A. Furness III, and everybody's favorite computer scientist from 1968, Evan Sutherland, who also premiered paint programs and bitmap displays and vector displays and all kinds of things, a pioneer in computer graphics, made his own called, I don't remember, it was just called VR, I think, but as you can see in the left photo there, the device was dubbed the Sword of Damocles because it looked like a very daunting piece of equipment hanging from the ceiling there with the helmet on your head, and that was a virtual reality and an augmented reality system and the first head-mounted display. So you could sort of move your head around with that horrible looking execution device there. Then in the 70s you got Aspen Movie Map, which was a really interesting experience. You sat on a leather chair, you had two like map displays for control, and you had these like remote controls. And what it did, it showed short video clips like transitioning through Aspen with like pre-shot footage. So that was an interesting sort of experiment into having a virtual experience. But as you can see, it's not very like encompassing feature. It's more like watching a screen and then turning your head to see the map displays. Then in the 80s, Jaron Lanier was the big did some research on virtual reality and coined the actual term for virtual reality. So it was called various terms before that, but Lanier coined the term, and he created the seminal goggles and glasses interface. So you could have data gloves that tracked your finger movements and your hand movements, and you had the very familiar looking headset there right now. It's a very nice picture of him playing around with it. Then came the dark 90s of virtual reality. Consumer-grade devices that had a lot of problems. They were both neck-breakingly heavy, terrible VGA resolution or even under VGA, very high latency in the head tracking, and just very, very narrow field of view. And on the left there you can see the Forte VFX1, which is the one I know best from the 90s, and the very infamous Virtual Boy by Nintendo, which basically made your eyes bleed with red LEDs that created the screen. So if anybody's ever had the chance to use the Virtual Boy, well, now you can emulate the Virtual Boy on an Oculus Rift, so you can get the experience of it with modern virtual reality hardware. So it's still there, and it's a lot easier to look at if it's emulated than the original hardware. And here we have a short digital art piece, a demo from 1996 from Finland. It's going to be in Finnish, but it's about virtual reality. So as you could see, they had a very, very good idea about the future. So if you play violent games in virtual reality, you actually start hitting your father in the face. So that remains to be seen how true that's going to be. So fast forward to modern day, and maybe, just maybe, we've gotten rid of the problems of VR from the 90s. So modern tech to the rescue. The mobile computing evolution especially has made it possible for virtual reality to actually work. And what we have right now is we were needed before was the fast head tracking sensor, so you don't get the horrible latency of your head moving and the image rendering after a few frames or so. And you have high resolution and low latency screens, and this is all made possible by mobile devices such as phones and tablets. So those screens are more than perfectly suitable for virtual reality applications as well. And you also have the modern GPU rendering pipelines for photorealism, thanks to NVIDIA, AMD, and Intel, and all those other guys. making sure that you can render photorealistic or not so realistic, but at least high resolution screens for virtual experiences. And today's hardware in virtual reality, you basically have two companies working on consumer grade devices, at least right now, and those would be Oculus VR, which already shipped DevKit 1 and just started shipping DevKit 2, and you have Sony's VR headset that just announced last week. And both are aided by research made by Valve Software, the gaming company. Valve decided not to do their own devices, but instead just made their research public to those companies. Michael Abrash is the guy at Valve, the old VGA programmer guy who's been working on that. So his work has especially been the low latency stuff, getting that to work. And here's some breaking news if you haven't heard. Just an hour ago, Facebook announced that they bought Oculus VR for $2 billion. So this is literally the latest development in VR. So Facebook decided to buy them off. So there's a quote from Mark Zuckerberg's post today, just an hour ago. He posted this on Facebook. So it's safe to say that these big players, these big companies really believe that VR is going to be a big thing. Then again, they bought WhatsApp for a lot more than that, but this goes to show that technology companies are worth shit if you don't have the users. All right. Just to keep you updated. I had to make that slide literally an hour ago, just like, oh, that's interesting. Then you have the augmented reality hardware. There's a lot more of those. You have the Google Glass, of course, the sort of heads-up display for reality. Not exactly something I'm interested in, but it's a thing. Cast AR is the interesting thing by Jerry Ellsworth, a very well-known American hacker that used to work for Valve Software, but decided to leave the company, and Valve really graciously allowed them to keep the technology, and they're working on their own on Cast AR. So that's sort of put the glasses on, and you can play these games on your tabletop. And you have Meta, which is an American company that also makes these glasses, their own sort of take on them. Then you have the two old companies that have been working on these for the past 15 or so years, which is Vuzix, that have made sort of army-grade augmented reality devices for many, many years. And you have the iTap, which is the device used by researcher Steve Mann, who is one of the pioneers of augmented reality displays. He actually has physically attached the AR glasses to his skull, and his other eye is constantly augmented by camera and image processing algorithms. So he physically can't remove his augmented reality device. So that's interesting. And so how do we render VR then? How do we get the virtual reality experience out of the headset? So the basic idea behind it is that you render two images, two viewpoints into a 3D scene from slightly offset viewpoints for each eye. And that produces the VR effect. On the image on the bottom there, you can see how you separate the different images for left and right eye from just a little translated position left and right there for each eye, compensating how your eyes are separated on your head. Then also because a classic VR headset right now, the design is that you have lenses on front of the screen and between your eyes and the screen. So you have to compensate for the optical distortion and chromatic aberrations, which are color fringing effects on the side of the lenses. And you can very easily compensate for both of these with a shader in modern GPU using a barrel distortion and chromatic aberration algorithm for fixing the color fringing effect. So that's the basic thing. So it's not that difficult to change a first-person game or a first-person camera view into VR view. Instead, you just render the scene twice from a different camera position, and you do this post-processing shader fix. So this was a really important part of today's VR experience, that you can just do this all in a shader pipeline instead of having to build your game engine around this fact. Here's a demonstration how it actually looks like in motion. you can see clearly demonstrated how the head tracking moves the camera. So that was coming from somebody's head movements. You can see the separate images for each eye and the sort of optical distortion effect of the round image going inside the lens. Then some fundamentals of the virtual reality experience. And this is something that both Michael Abrash and John Carmack of Oculus, who used to work for id Software, working on Doom and Quake and all those seminal 3D games, is that the one thing they constantly mention and they constantly want to point out, and I agree with them, having experienced the DevKit 2 from Oculus myself, is that the most important thing in VR isn't photorealism, it isn't even latency, it's the actual feeling of presence. So for me, the first Oculus DevKit 1 was missing that. So you didn't get the feeling of presence, actually being present in another world by fooling your eye to think that what you're experiencing is reality and not a computer-generated image in front of your eyes. So the most important aspect of any VR software and hardware experience is to get the feeling of presence for the user. And how you get the presence, you need a low latency display that'll render the image you want to show as quickly as possible. So there's as little of motion to photon latency as possible. So literally the time your head takes the first movement to the time that the light reaches your eye from the headset. Removing that latency there is key. And also removing motion blur as much as possible makes you feel like your eye is perceiving reality instead of a generated image and constantly fooled by small imperfections. And with a good presence, you also you'll fool your inner ear. So games like, if anybody's played Mirror's Edge, where you walk on rooftops and you can fall and move like a parkour person there, you can definitely feel like you're going to puke and fall. It's a very disconcerting feeling, but at the same time, a very, 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 something I've never got from watching a monitor at least. And also very important element to presence is a 3D audio. So humans are extremely accurate at pointing out where things are coming from into their ears and pinpointing audio location. So having really well-defined 3D audio in your engine is really important. So you can actually turn your head to look behind you and see where the sounds are coming from. And what virtual reality and augmented reality are not just a new type of display or a gimmick or anything like that. To me, virtual reality is a new kind of medium that is separate from anything that's existed before. It definitely does borrow from a lot of different things and has common things with games and 3D cinema and movies and all that. But to me, it's a new kind of medium, and the experience, the content, software content needs to be built around the fact that you can't really just rehash what you've done before. You have to think your software from ground up again for virtual reality. And let's get to some of the artistic usages. How do we interact with this virtual world now that we're able to render it and get the sounds working? Here are some things you can do now, right today. So you have the classic data gloves pioneered by Lanier in the 80s. They've been around. Nintendo even did their own data gloves. It's been around even before I was born. So that's an old steak. Then you have the 3D joysticks, like you have the Hydra controller there. So you palm the ball thing there, and you have those V-motion, remote kind of like things in your hands. So you can do like kind of good like sword-like motions and emulate the feeling that you're gripping something in your hand. So it's good for games at least. Then you have the no tactile feedback version of where you have the leap motion controller where the thing is tracking your fingers in the air, or like Kinect. So it's using infrared to track your fingers or your hands or your whole body. You have that one. And then you have the Sony's method of doing VR on PS4, which is having the Move controllers that track those glowing balls on your hands, the controllers with the glowing colored balls, and based on the PSI seeing those, it calculates the depth and the distance between your head and all that. So all of these have all sorts of upsides and downsides, of course. Data gloves are probably the best ones, but of course you're literally holding mittens in your hands, so that's sort of always a bad thing. With 3D joysticks, you have a really low latency, but it's a kind of an unwieldy thing and doesn't really work for all kinds of experiences. With leap motion, you're losing the sense of tactile feedback and sort of feeling that you're actually touching something. And with camera, you have latency because you have the first look at the camera image, analyze that, turn that into 3D movement. So you'll have more latency because you'll actually have to do some image processing tasks. And then some artistic usages in games. And for me, I think games are going to be the killer app of VR, and there's been a bunch of games announced for Oculus and a bunch of demos and all kinds of things on their forums, and I've been looking through them, but I don't believe there's a killer app for VR yet. That's something I'm still looking for and hoping it's going to come out at any point now, but it's still, the word is still out there. And to me, games have always embraced new rendering and input device technology in the past, and the most clever ways of you taking this technology that companies produce and making them into something else, using a VGA card to render 3D scenes like in Doom and Quake and all that. And I think VR and AR will have a similar path, but what we're still waiting for is a game that'll just redefine or define what virtual reality actually is. And some existing software that's not built for VR, but it's kind of similar in many ways, like iPad games that use the orientation sensor in the pad or the phones. I think those could work in VR as well, and here I have a demonstration of an app made by Radiohead and some software companies that works around that concept that I think that could work quite well with virtual reality as well. So here you have tracking. Instead of moving your head, you move your hands in the forest, and you can draw these weird things and look at them. It's not really a point, it's just more of an artistic experience than a game, but I think software like this could definitely work in a virtual environment as well. And previously I showed you a short clip of this game, and I'd like to show the whole video because I think of all the games I've seen so far, this has the most potential of being a really big thing for VR. So take a look. This is on Kickstarter.
If there's a table in the kitchen and you look away from it, is it still there when you're not looking? There are laws of physics that bind reality and ensure that your observations are always consistent. But what if something damaged these laws? If the laws were no longer in place the moment you looked back? Anything could be there. This is the story of how these laws are broken.
Hello, my name is Tomasz Marencik and I'm the creator of Sightline. I got the initial idea shortly after I saw the Oculus Rift on Kickstarter. The idea of actually looking at the game world like you were really there fascinated me. And I thought, what if I could use just the act of looking as gameplay mechanics and change things outside of the field of view.
That's awesome. You like look away. Oh, that's sick.
But if you're not looking,
you can see the rest of the video on Kickstarter, but that was definitely something, because my initial thought on VR and head tracking would be that the key element in gameplay would be the fact that you can turn your head, and you should use that in some sense. And so far, that's the best implementation of that idea that I've seen. My own idea is called the patient, and this is something I'm not actively working on, but this is something I've toyed around with for a few months in my head. And the idea is that you are a quadriplegic patient in a hospital, and you can talk, you can't blink. The only thing you can do to communicate with other people is to turn your head to say yes or no and make head movements, and you're literally just stuck in a hospital bed. So I was thinking of it would be a really interesting sort of just both to put you in that position to experience the horror of not being able to move, being stuck in a bed, and also the fact that you couldn't communicate with other people. So you could build an interesting narrative around the fact that you can only answer in yes or no questions, or try to get people's attention by moving your head. So that's something I would like to build on for VR. So if I ever get around to working on VR software myself, please don't steal my idea. This is mine. So you heard it here first. Then let's get to the more sort of traditional arts, which would be moving arts and live arts. And of course, we all know what the killer app of moving arts in VR is: pornography. That's always been the key innovation in all areas of new resolution screens, the internet. Pornography has always been there first. And you have, of course, going to have VR movies and TV. That's sort of a no-brainer to me. How I think that's going to pan out is that you could experience a story, like a traditional movie-like story, in multiple viewpoints. So you could follow characters around, experience the story from their eyes in a point of view kind of way. And of course, you can have a virtual cinema. Oculus actually has a software for this, so you can play your AVI files in a virtual cinema environment. You can sit on a chair and see the curtains and everything, and then on the screen the movie is actually playing. So this is really interesting, because I personally don't really like 3D cinema, like going to the movies, having those unwieldy glasses that don't really work except when you're sitting in the smack middle of the theater. It's really difficult to calibrate properly, but virtual reality devices will actually give new life to these 3D movies we're making right now, because then you can actually move your head and get the perfect viewing position every single time in your virtual 3D cinema experience. So that'll probably give it some additional life cycle there. And of course, this is an interesting one. What about experiencing concerts and mass events through VR? So somebody will stream a concert on the internet, and everybody can just buy a ticket and see that concert from whatever position, be on the stage with the band and all that. So I think this is definitely something that will happen in the coming years. Then some artistic usages pertaining to virtual presence. And what I mean by that is that you could have something like virtual museum visits. So just imagine something like the Guggenheim or MoMA putting all their art pieces, their installations on a virtual museum that you could walk around. This idea has been around ever since VRML came out on browsers in the 90s, but I still think it's something that you could do. It should definitely work. Then just having a single art piece that's released as a VR experience. You can move your head, look around it from different angles. Maybe even something like this then, so you could have a more immersive, collaborative experience, so multiple people can be looking at something at the same time, maybe comment on it, maybe even change it, play around with it. So instead of just having a multiplayer game, you have more of a multiplayer art experience there. And this was something I was thinking as well. So having the headset is a very intuitive camera control for something like modifying 3D models and 3D volumes. So we could do a virtual sculpturing software using VR. So you could modify this virtual mud or virtual clay with your hands and move your head around to look at it from a different angle, go really close to see the details and all that. And coming from the demo scene and being a digital artist myself, this is of course the sort of forefront of virtual experiences in the art world would be the demo art. So combining a traditional demo-like experience with a user-controlled camera is of course the simplest one. So just take a kind of demo that's experienced from first person and just have the user be able to look around. And you could also do augmented reality demos, so you have some sort of marker on your tabletop and the demo plays out there. You can walk around the table, for example, see it from different angles. It's fixated in a single physical space that you can watch. And if you have an augmented reality device that can do hard AR, so the difference between hard and soft AR would be that hard AR blends in with real elements, and soft AR is sort of, you can tell what's augmented and what's not. So more of a overlay, whereas hard AR would be something that you're literally inserting virtual things into your world. And to me, the first thing that I came up with, like when I heard about the Oculus, I was thinking of doing this software for augmented reality that you walk around and it turns everything into an 8-bit like pixel visual. So that's, to me, I would like everything color fading from true color palettes from every single surface I can see. So when somebody finally makes a hardware that can do that, you could be sure I'd be wearing that every single day. And you can also even run your Amiga in VR. There's been a few interesting emulators that basically you have this 3D model of a virtual living room with your computer there in the 80s, He-Man comics on the floor and everything, and then literally having the Amiga image on the screen. So you can even do that. You can have your emulator in a virtual environment. So I think that's definitely something you could use. And here's a video of a really interesting, more of an experimental usage of VR in art called Body Swap. So here you have two people that are able to feel like what the other gender feels like in their body by synchronizing their movements with VR to each other. hopefully what you saw there wasn't the future of sex. And here's the latest from Finland. So water as a movement medium for virtual reality, definitely interesting. Some words about the future. I think what we still could do a lot to make the devices we have right now that's been announced a lot better would be to get rid of the cables, of course. Right now, all of them, even the Sony one, is dependent on cable connection. So as long as you have something that's physically attaching the headset to something, it's going to be a bit clumsy. One thing, of course, is to make it even smaller than it is right now. So compared to whatever we had in the 90s, it's already quite lightweight and nice, but still you could get it to a lot smaller size, even to glasses size. And you can always increase the resolution. Right now we have full HD panels, but there's really no upper limit to that. As any increase to the resolution will be just an increase in quality. And of course, refresh rate is always going to be a big improvement as well. Even though 60 Hz, it's kind of nice, but if you can double that, it's even better. And here's an interesting idea. Instead of just having the headset as a stupid display device, why not just replace the whole screen with a modern Android device, for example? Generate the virtual reality footage on that instead of being dependent on any sort of external system for that. So build a all-in-one package out of the virtual device. And of course, the real future is to go with contacts and then hopefully the data jack to the neck at some point, just to replace all your senses with a digital feed instead, hopefully. And we can always improve the input devices we have right now. Those are the most rudimentary things we have. There's a lot of room for improvement for manipulating the virtual world. One thing that Oculus said to be working on, but haven't put in Dev Kit 2 yet, and Sony haven't announced at least, is to track the pupils of each eye, so you could also tell on which part of the image is the user looking at, and which objects in the virtual world, so you could do a nice depth of field effect and focus your eye on perfectly on these virtual objects by tracking your eyes. And you could probably do it with having infrared cameras inside the headset, shooting a video of your eyes and doing a calculation based on that. Of course, you could also just scan your whole body into the virtual reality or your own objects. So combine what we already have in Kinect with virtual reality. And there's been multiple of these devices, so moving around in a world, instead of having to move around in a room, you could move in place. So having a treadmill or having OmniX type of device where you have special shoes that glide on a surface, so you can walk around in a virtual world. Right now, it's mostly done with controllers instead. And incorporating physical art mediums into virtual ones, so using actual like paint brushes and sculpture, like rock, all kinds of different mediums you already have in different art forms, and somehow either real-time scanning or some sort of method of inserting this into a virtual world, so you actually have something to touch, but you can also augment it with digital imagery. And like I've said many times during this presentation, I don't think the hardware isn't that important. It's good enough. What we need is the killer app. We need better software. We need software built for VR by people who don't have the burden of thinking like 2D or 3D rendering. All right. Thanks a lot for listening, and I hope to see you in cyberspace.
Sorry about that microphone trouble. Do we have any questions? There we go. Here.
I noticed a trend of a lot of dystopian VR environments. One, why do you think that is? And two, have you seen any VR utopias?
I'd say definitely the dystopian vision has always been the more key element of virtual worlds in movies as well, like The Matrix and Johnny Mnemonic and all that. So right now, I guess there aren't really that many. It's kind of a negative thing to simulate the reality, but of course you could do a really happy world. Maybe somebody can do that anime pastel world at some point. It's bound to turn out, but for some reason the more interesting ideas right now have been more of in the negative side of things. Thanks.
Thanks.
Anyone else? There you go.
What's your take on the Facebook acquisition?
I'm just going to say one word, and that's Oculus will. That's the sort of most dystopian concept I can think of. But I guess Facebook has the user base, they have the money, they have the power to move worlds to get things done. So at least they might be able to do the proper VR chat application, which I think is one really important thing. So you can physically see people in a virtual environment and interact and talk with them. So I guess that's what they want, at least, I'd guess. It's not neither good or bad, in my opinion. It's a thing. I think they will have a lot of freedom to work on their own stuff, even though they've been bought out right now. So if Zuckerberg isn't a total idiot, he'll give them the freedom to move like they have so far, because they're one of the most clever engineering teams in the world.
Any follow-ups? Okay, thank you for your session, and we will continue the next one in about 20 minutes.
Thank you.
Thank you.